Okay, my friends, let's see if this works this time. So I want to do, already did, I'm going to start a fresh one because I just recorded and didn't record. So a sign diagram, all right? Let's go over one. Let's start with one that's not too hard. So I'm on 2F. And this one I'm going to just kind of give you an overview in case you're a little bit lost or a little fuzzy on what, excuse me, sign diagrams are. So how about we do, let's start with 2B, all right? 2B. So we're given an already factored quadratic function, x times the quantity x minus 3. So I want you to first of all recognize that, because typically what they'll do is they won't have it factored at, it would typically be x squared minus 3x. Do you see that? If you distributed the x here, that'd be x squared. You distributed it here, that'd be minus 3x. So what they're doing in this problem is they're already factoring and they're starting it right here. Once it's factored, it's easier to find the roots, because that's part of the sign diagram, is we want to find the 0 points. What we're really interested in is what's going on around the 0 points. To the left of the zeros, is the function negative or is it positive? To the right, is it negative or is it positive? So what you're thinking of, if you want to go old school, it's like you're putting in different values for x and you're seeing what comes out of the function. And you're not so interested in the actual values, just the sign. Is it positive or negative? Because we're trying to learn how to quickly visualize these graphs, and we don't really care about exact points, but we want to know overall, is it positive, negative. So just for example, if x was negative 10, I would put it in for the x. I would put it in for the the y, if you will. I'm trying to figure out what the y is or what the function is. So it's negative 10 on the outside. I'll just write it. It's negative 10 on the inside, minus 3. So negative minus 3 is always going to be negative. So that inside is going to be negative times the negative on the outside. Therefore, without even calculating it, I know it's positive. So when x is negative 10, the function is positive. So what you could do is start guessing a bunch of numbers and kind of start to get a feel for what's going on, positive, negative. But it'd be much more intelligent to find the 0 points first. So we want to try to figure out the roots, and then we can know those are the tipping points, if you will. So looking at this function, hopefully you remember. Sometimes it's confusing, so easy. That's the 0 right there. X. When x is 0, that's one of your roots. When x is 0, the whole function automatically becomes 0. It doesn't matter what's inside the parentheses, because 0 times anything is 0. So that's one. And then the other one, if you remember how to do this, you just set that equal to 0 and solve for x. So that tells you when x is 3, and of course just think about it, 3 minus 3 is 0. So when x is 3, that quantity becomes 0, and once again, who cares what's outside of it? It's going to all go to 0. So I have my two zeros. So 0 and 3. And what we want to know is, well, we already know that to the left of 0, when numbers are negative, the function's positive. We don't know what's going on here and here. And rather than writing it this way, sign diagrams, we typically write them like this, horizontally. You write the x-axis. The first thing you're going to do is put in your two 0 points. So when x is 0, that's 1, and then when x is 3. And now what I'm going to do, this one's pretty simple. So I'm not going to write out, you could, remember how we used to do it, you could write each function and chart what's happening, and then ultimately what happens when you multiply them. But this one's pretty straightforward, so I think we can just do it in our mind. So we know when x is 0, it's a 0. We know to the left, it's positive. The function is positive, right? Like if we put in negative 10, and we calculate it out, we know the final answer is going to be positive. Now, to the right, let's just pick any number. Let's pick 2. So when x is 2, I stick that in. Actually, I could put it here between it, right? So it's going to be 2 times 2 minus 3. Okay, well, 2 minus 3 is a negative. Negative times positive. It's going to be a negative. So this is going to be negative. And then when you go to a number bigger than 3, let's say 5, get rid of that. And you put that in, 5 times 5 minus 3. Well, 5 minus 3 is a positive number. A positive times a positive is a positive, of course. So that's my sign diagram for the function. And I didn't bother doing each one. If I wanted to do each one, I'd be okay, well, when x is to the left, x is negative, positive, positive. X minus 3 is going to be, right, when it's like 0 minus 3, that's negative. That's negative. That's positive. That's for the 3's. And then when you multiplied them out, remember how we did that? Negative times a negative is a positive. That's where it is. Positive times a negative is a negative. Right, we already got that. And positive times a positive is a positive. So if you want to be very careful, you could write each row out for each term, I guess you'd call it, and then figure out when you multiply the two together, what's the overall thing. Or some of them you can just do in your head. So hopefully that helps with that first one and kind of giving you an overview.